Hi, my name is Nurul, Aqilah Binti Hisham. My matrix number is 2019435466. So today I would like to introduce to you our members. We choose a mixture problem in application of first order linear differential equation for our assignment. Mixing problems are an application of separable differential equations. They are word problems where we need to create a separable differential equation based on the concentration of a substance in a tank. Usually, we have a substance like salt that is put into a tank of water at a certain rate. At the same time, the salt-water mixture is emptied from the tank at a certain speed. They are always perfectly mixed, and we are asked to model the concentration in the tank at a given point in time.
Hi, my name is Syazwani Syakirah Binti Mohamad Azuan. My matrix number is 2019203764. The problem statement for our assignment is a 150 gallons tank begins with 100 gallons of pure water. A prime solution with a concentration of 3 pound per gallon of salt enters the tank at a rate of 3 gallon per minute, and the well-stirred mixture exists at the same rate. Find the first question, which is the amount of salt in the tank at any time, t, the limit value for the amount of salt in the tank for question 2. For question 3, time required for the amount of salt to reach 90% of the limiting value obtained in 2. The fourth question, time when the brine exciting the tank has a concentration of 2 pound per gallon. And the last question, time when the tank will be full if the brine leaves the tank at a rate of 2 gallon per minute.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Jafni, and in this slide we will discuss about the problem statement that I have been given, which is the question of one Roman and two Roman. So first we have to find the inflow and the outflow of the question. So the inflow, the dLdt is given, which is 3 gallon over min, and the dA over dL is 3 lb over gallon. And it is also given the maximum of the tank is 150 gallon, but the tank only contains 100 gallon of raw water. For the outflow, the dL over dt is 3 gallon over minute, and the dA over dL is A over 100 lb over gal. Question for the one Roman is, let A be the amount of salt in the tank of any time t. So the dA over dt is R inflow minus with R outflow. So we have to insert the R inflow, which is dA over dL multiplied with dL over dt, and minus with the outflow, which is the dA over dL minus with dL over dt. We insert the value, which is 3 gallon over minute multiplied with 3 lb over gal, and minus with 3 gallon over minute and multiply with A over 100 lb over gallon. After that, we will get the equation is dA over dt equals to 9 minus 3A over 100. So we move the negative 3A over 100 to dA over dt, which we will get dA over dt plus with 3A over 100 equals to 9. As you can see in the slide, we can get the P equals to 3 over 100 and Q is 9. And then we insert the formula of IF, which is E with the power of integrate P dt. We insert the value of P, which we will get E the power of integrate 3 over 100 dt. And then after we simplify it, we will get E the power of 3 over 100 t. So for the next step, we use the formula of AIF equals to integrate QIF dt. So we insert the AIF, which is AE the power of 3 over 100 t plus C after we solve it. And AT equals to 300 plus C over E the power of 3 over 100 t. So to determine C, t equals to 0 and E equals to 0.2. So we will insert 300 plus C over E the power of 3 over 100, 0. So we will get 0 equals to 300 plus C. So we will get C equals to negative 300. So AT equals to 300 minus with 300 over E the power equals to 300 plus C. So we will get C equals to negative 300. So AT equals to 300 minus with 300 over E the power of 3 over 100 t. So we have to let t equals to infinity, and we don't know the value of A. So A infinity equals to 300 minus with 300 over E the power of 3/100 infinity. So we will get 300 LPS.
To solve question 3, which is time required for the amount of salt to reach 90% of the limiting value obtained in 2, we can use equation from question 2, which is AT equal to 300 minus 300 per E 3 per 100 T. So we can put in the A, which is 270 pounds, which we will get T is equal to 76.75 minutes. For question 4, time when the brine exciting the tank has a concentration of 2 pounds per gallon. So from this question, we know that the C for this question is 2 pounds per gallon. Before this question, we also find that to find C, we get that AT per 100. So, which 2 pounds per gallon that we found from this question, we can compare it to the first equation that we found for C, which is the A per DL outflow. The answer for this question is T is equal to 36.62 minutes. For the last question, which is time when the tank will be full if the brine leaves the tank of rate. For the last question, which is time when the tank will be full if the brine leaves the tank at a rate of 2 gallons per minute. So from this question, we know that dL per dt is equals to 2 gallons per minute. In this question, we also know that the tank maximum is 150 gallon, and also the tank contains 100 gallon. So with 100 and 150 we get from the first question, we can put it in the formula, which we get 100 plus 2t is equal to 150. The final answer for this question is t is equal to 25 minutes.
In this discussion, we applied the mixture problem formulation to find the solution. The amount of salt in the tank at any time is 300 minus 300 over E, the power of 3 over 100t. The time required for the amount of salt to reach 90% of the limiting value that obtained in 2 is 76.75 minutes. The time when the brine exciting the tank has a concentration of 2 pounds per gallon is 36.62 minutes. The time when the tank will be full if the brine leaves the tank at a rate 2 gallons per minute is 25 minutes.